Common ectoparasites do not actively hunt. They wait. They employ questing, anchoring to vegetation and extending their front legs to intercept passing animals. The conventional pharmacological response to this threat relies heavily on the administration of systemic neurotoxic parasiticides. This diagram illustrates their mechanism of action. Whether applied topically or ingested, these chemicals must be absorbed directly into the animal's bloodstream to become lethal to the parasite. The operational paradox of this method is clear. To eliminate a purely external vector, the host's entire internal circulatory system must be weaponized. Zooming in on the liver, we see the biological process for handling neurotoxins, hepatic metabolism. The liver breaks down these chemicals into excretable metabolites. Over years of repeated applications, this creates a cumulative toxicological load. Processing slows, taxing the liver over the pet's lifespan. An alternative approach, natural intelligence, focuses on parasite deterrence by modifying the microenvironment on the surface of the skin, leaving the host's internal biology untouched. Bypassing the liver entirely requires transitioning away from a single systemic chemical strike and instead constructing a multi-layered, localized biochemical barrier. The outermost layer of host-parasite interaction is not physical contact, it is olfactory detection. Looking at a cross-section of a parasite's anatomy, we see specialized sensory structures, like Haller's organ. This structure acts as a radar, specifically tuned to detect the unique geometric shapes of carbon dioxide plumes and host semiochemicals drifting in the air. Botanical ingredients like lemon and peppermint are dense in volatile monoterpenes. Evaporating at skin temperatures, they create an aromatic shield beyond the fur. This dense molecular cloud overloads the parasite's olfactory receptors, failing to bind with host semiochemicals, rendering the animal invisible. True biological deterrence works proactively. It prevents physical attachment before it begins by blinding the vector's primary tracking mechanism. If the olfactory barrier is breached and a parasite makes physical contact, the secondary line of defense relies entirely on the immediate chemical environment of the skin. Clove oil provides this defense through its highly active phenol compound, eugenol. This microscopic view of the epidermal surface demonstrates eugenol acting as a natural antiseptic. It actively regulates the native microbiota residing on the animal's coat, preventing harmful opportunistic bacterial strains from replicating. Maintaining this precise bacterial balance is critical. It prevents microscopic bite sites from becoming severely inflamed or necrotic. By stabilizing microbial homeostasis, the skin shuts down secondary infections that typically exacerbate tissue damage and attract further parasitic attention. Often, the primary behavioral threat to the structural integrity of the pet's skin barrier is the host itself, driven by the itch-scratch cycle known as pruritus. Self-inflicted mechanical scratching structurally tears the stratum corneum, creating wide-open pathways for deeper infection. To counter this, highly targeted botanical anti-inflammatories like oats and peony root are introduced. In this cross-section of inflamed dermal tissue, we see the mechanism of action. Beta-glucans and peony florin penetrate the upper dermis, binding directly to localized immune cells. These compounds biochemically downregulate local inflammatory cascades, silencing the nerve signals that trigger the urge to scratch. Rapidly arresting pruritus provides immediate relief to the animal while preserving the intact physical canvas required for all further biological defenses. That physical canvas, the outermost physical boundary of the host, is the stratum corneum. We fortify this boundary using castor oil, driven by its primary active structural component, ricillinic acid. In this microscopic time-lapse view, we see the lipid compound at work. It rapidly spreads to form a smooth, contiguous surface, filling over existing microabrasions. This ricillinic acid layer creates a viscous, hydrophobic seal that mechanically impedes the mobility of any ectoparasite attempting to navigate the skin. This lipid seal also serves a secondary structural purpose. It locks in the host's transepidermal moisture, preventing the skin from drying out and becoming brittle. For a biochemical shield to endure environmental degradation, it must be reinforced by a resilient physical lipid barrier. Shifting our physiological perspective from the external epidermal layers inward, we arrive at the gastrointestinal tract. An isolated external defense is inherently vulnerable if the host's internal homeostasis is compromised. We must establish a systemic first aid kit. The core of this internal protocol is wormwood, which introduces specific active bitter terpenes, predominantly artemisinin. This gastrointestinal schematic illustrates how internal gut hygiene modifies the host's milieu. Artemisinin molecules optimize the microbiome, creating an inhospitable environment for internal parasites. This modulation doesn't stay isolated, it radiates outward, supporting systemic immune resilience, extending all the way to the dermal layers. True parasitic resilience is bidirectional. It requires a protocol that protects the organism from the outside in and the inside out simultaneously. This macro schematic displays the unified ecosystem defense model. Olfactory disruption, cutaneous homeostasis, lipid sealing, and internal gut hygiene function as a single synchronized engine. This entire defense architecture operates with zero reliance on systemic neurotoxic suppression. The liver remains highly efficient, free of metabolic load. Traditional chemical treatments impose a destructive metabolic tax on the body. Natural intelligence relies on constructive, localized environmental modification. By treating parasite defense as an exercise in biological deterrence rather than systemic poisoning, we preserve the animal's internal harmony for years to come. Protect with love, not chemicals. With love, Little Wolfie and Fence.